My name is Hayden Holligan. This is my submission for Sci 206, the Science of How Things Work. I will be talking about the science of a pressure cooker. Essentially, the pressure cooker allows you to utilize pressure to cook things faster. I thought it'd be fun to do this with me cooking and showing you the final product, making some sort of pot roast. I'm not really sure yet. Let's get into it. Sick. So, of course, a pot roast includes vegetables. I'm using carrots, onions, and garlic, as well as a can of tomatoes. I'm not really sure why I included the tomatoes, but let's go with it. I'm trying to keep all of the vegetables around the same size so they cook at around the same time, so nothing is overly mushy or undercooked. What you'll see after I chop the vegetables is searing the meat. This entire project could have just talked about searing and browning and all of that, but I'll talk about it for about 30 seconds. So the scientific process behind searing is actually called the Maillard reaction. This reaction is when proteins, such as in meat, or sugars, such as in sugar, break down and caramelize, and quite obviously start to turn to a rich golden brown color. This flavor is the same that you experience in seared meats, roasted coffee, roasted vegetables, some fried hash browns, anything. You might also notice that I dried the meat very well. The Maillard reaction won't happen if there's moisture, so you need to remove as much moisture as you can from whatever you're cooking in order for the browning to occur. This is why you need about 5 minutes of cooking onions before they start browning, because the moisture being released is preventing them from browning. You'll notice later that I took the pot roast out. It wasn't done searing. I transferred it onto the stove instead. I was getting impatient, and there's two reasons the stove is better for this. First of all, the stove's larger element uses about 3,000 watts at max power, while my roommate's electric pressure cooker can only go up to about 1,000 watts at the highest setting. So naturally, the more energy you use, the higher heat you can generate, which is better for searing. Not shown in this video is the pan I used to sear the meat. I used a nice simple cast iron pan. As the name suggests, a cast iron pan is made of iron. This is a poor conductor of heat, as in the pan doesn't heat evenly, but it holds on to heat very well. It has a high heat retention. This is very good for searing steaks because you want the pan to stay as hot as possible when you drop the meat in. The combination of the cast iron and the high-powered stove means I can sear the meat much faster. Okay, enough of that. Let's start talking about why we're here. Pressure. So how does a pressure cooker work? First, we have to understand how food cooks normally. Obviously, you cook food with heat. But the speed at which food can cook is limited by the boiling temperature of water, 100 degrees Celsius. No matter how high you turn your burner on, those dried beans are still going to take 2 or 3 hours to cook. So how can we improve this? How can we make cooking faster? This is where a pressure cooker comes in. As I said before, a pressure cooker uses pressure, obviously, to cook food faster. But how does pressure help food cook faster? A pressure cooker seals in all air and water from escaping from the container. As the water heats up and boils, it evaporates into steam. We also know that as the temperature increases, air will expand. Both this and the steam will increase the pressure inside the vessel. As we know, pressure is proportional to the temperature. This means that water has a different boiling point at different points in pressure. The boiling point of water in the ocean down below in Marianas Trench is different from the boiling point at the peak of Everest. This is because different altitudes have different amounts of pressure. But unfortunately, most of us are limited to standard pressure. The pressure at sea level is 14.7 psi. Inside the pressure cooker, when it hits its peak of pressure, it's about 30 psi. This difference means that water boils at 120 degrees Celsius instead of 100 degrees Celsius. Now, 20 degrees Celsius doesn't sound like a big difference, but this difference drastically reduces the cooking time in meats, legumes, vegetables, you name it. Because not only is the water around the food raised in temperature, the water inside of the food is raised in temperature. This helps it cook faster as well. The starches break down quicker. The collagen in meat breaks down into gelatin faster. The fibers in beans and lentils soften quicker. This means that instead of spending 8 hours in a slow cooker, that pot roast can be done in less than an hour with a pressure cooker. We're arriving at the final tasting and seasoning step of what I will call a stew, and the final result. I hope you learned something today and enjoyed the video. Thank you.